Hey everyone, now that you have cleared integration and differentiation, it's time to move on with the calculus journey, and we'll now talk about differential equations, a rather simple topic. So differential equations, by its name, are basically equations that involve a derivative, right? So let's recall some knowledge that we have learned so far. We have y equals to x squared plus 2, right? This is a standard equation. If you're to differentiate with respect to x, you get dy dx on the left side and 2x on the right? Basically, bring down the power to the front and reduce the power by 1. If we just consider the second equation alone, this is a example of differential equation. So what defines a differential equation is basically an equation that involves a derivative, right? Any derivative is possible. So you can have something like dy dx equals to any function fx or any function gy. Not necessarily be y or x either. You can also have an equation in terms of u. So it's if you have a function of ku. Anything is possible as long as there's a derivative inside. It can also involve higher order of derivatives, right? So let's say you have the 2y dx2 equals to fx or whatever, or say gy or ku. It could also involve a sum or a combination of different types of derivatives. So let's say I have the 2y dx squared plus 5 dy dx plus, I can even have y inside as well, equals to, let's say, for some function fx. This is also possible. Another example actually is what we call by higher orders, right? Higher degree of the differential equation. So higher degree meaning the power. I'll go through this in detail again later, but these are some examples, okay? So all these are basically your differential equations. So I'll now go on to more specific terms, all right? So firstly, we have the order of the differential equation. Order of DEs. Basically, the order of DEs refers to the highest derivative, nth derivative, right? So let's say my highest derivative, to the highest nth derivative. So let's say if I have my equation, the highest derivative is, let's say, d5y dx 5, then it will be of order 5, right? So if I have d5y dx 5 plus y equals to fx, then that would be order 5. If I, let's say, have d3y dx squared plus, dx cubed, d2y dx squared equals to 0, then this would be order 3. Okay, now then we talk about degree, right? Don't worry, you're not tested on this. It's just information for you. The degree of differential equations refers to the highest power of any derivative. So it includes the zeroth derivative as well. So let's say you have this equation. Let's say I have dy dx whole thing cubed plus, let's say, d4y dx4 equals to some gx. Then my degree would be, this would be degree 3. Order would be 4. Okay, because my highest degree is a cubic, so it's degree 3. The highest order basically is the 4th derivative, so it's order 4. For the H2 Math syllabus, you're only required to solve the 3 following types of differential equations. So number 1, you have dy dx equals to, for some function fx. Number 2, you have dy dx for some function gy. And then lastly, number 3, d2y dx2 equals to, for some function fx. So these are the 3 main types of differential equations that you will encounter in your entirety of your H2 Math journey. But you encounter some more novel ones, but the questions will help you to reduce those equations to either of these terms through substitution. All right, so don't worry about those. We'll talk about how to solve differential equations in the next few videos. But for now, these are the only three equations that you need to know, and that's it for our introduction to differential equations.